Hi everyone, and welcome to Revised Chemistry with Mr. B. In this video we're going to be looking at other examples of electrolysis, in particular the electrolysis of solutions. So remember, the thing that you're doing electrolysis on must be in a liquid form so that the ions are free to move. So here I've got some copper sulfate solution. I've got an electrolysis cell which consists of 2 carbon electrodes. The one that's connected to the positive is the anode. Remember, panic, positive anode. The one connected to the negative side of the power pack is called the cathode. Negative is cathode. So I'm going to put the copper sulfate solution in the electrolysis cell, making sure that the electrodes are covered, and then switch the power on. And then we're going to come back to this in 5 minutes time to see what's been made at each electrode. Let's have a closer look at what's being made at the positive anode. So if we get really close to this, we can see at the positive anode there's clearly a gas being made. We can see that fizzing away quite nicely. And now we're going to take a look at what's made at the negative cathode. So at the cathode, we can see that we've got some copper forming here at the cathode. So we've got a gas being made at the anode, and we've got copper being made at the cathode. So we're now going to have a look at how that's happened and what that gas is that's being made at that electrode. We're going to take a closer look now at the electrolysis of solutions. Before we do this, make sure you've got a good understanding of the electrolysis of molten compounds. If you need a reminder about that, I'll put a link up here now to take you to one of my previous videos. So how is it different when we've got a solution? Well, to make a solution, you get your ionic compound and dissolve it in water. So you can see on the diagram, we've also got water molecules now. And when we pass electricity through water molecules, we find that the water molecules break apart and make these two ions, hydroxide ions OH- and H+ ions that are hydrogen ions. We say the water molecules dissociate to produce hydrogen ions and hydroxide ions. Let's take a look at the electrolysis of copper sulfate solution, which is the one I showed you in the video. So it's copper sulfate solution. So as usual, we've got copper ions and sulfate ions, just the same as if it was molten. However, because it's in solution, we've also got the water molecules which break down or dissociate to release hydrogen ions and hydroxide ions. So it does mean in this case, we're going to have 2 different ions going to each electrode. So let's have a look at how it would look after the electricity has been on for a few minutes. So as you can see, the anode is positive and opposite charges attract, so that will attract all of the negative ions. In this case, that's the sulfate ions and the hydroxide ions, the OH-. The negative cathode is going to attract the positive ions, which in this case is copper ions and hydrogen ions. So let's have a look at what's going on at the cathode. We need to decide, is copper going to be made or is hydrogen going to be made? And for the cathode, the rule is the least reactive one is discharged or made. So you need to know your reactivity series for this. If you've forgotten your reactivity series, I'll put a link up now to one of my previous videos all about the reactivity series. And when you do know your reactivity series, we know that copper is lower down the series than hydrogen. It's less reactive. So in this case, copper is made because it's less reactive. Let's take a look at what happens at the anode. So we've got a different rule for working out what's made at the anode. The rule is if we've got a halide ion, such as chloride, bromide or iodide, so the ions of group 7 halogens, then the halogen will be made. So if we have a chloride ion present, it would make chlorine. If we have a bromide ion present, it would make bromine, for example. If we haven't got a halide ion, then oxygen is made from the hydroxide ion, the OH-. So in this case, we don't have a halide ion, so oxygen is made from that OH- ion, and they were the tiny bubbles we saw on the electrolysis cell at the start of this video. Let's now think about the half equations at each electrode. So at the cathode, we've got ions changing into atoms like we always do during electrolysis. So we've got copper ions changing into copper atoms. We need to put 2 electrons somewhere, so they go on the left so that the charge balances. So we've got 2 plus and 2 minus on the left is 0 charge, and 0 charge on the right of the arrow. Now the anode equation is one you'll just have to remember. It's not something you could really work out for yourself. So we start off with 4 hydroxide ions to make 1 molecule of oxygen, which is what we saw at the start of the video, the bubbles of gas, 2 molecules of water, and 4 electrons. So make sure you watch the electrolysis required practical video and also the one that follows that, which talks you through some exam questions, because then you'll see many more examples of electrolyzing solutions and working out what's made at the cathode and the anode. So please remember to subscribe to my channel. Thank you for watching.